Assalamualaikum warahmatullahi wabarakatuh. We will talk about Schottky barrier diode in our presentation. Before we begin, I will introduce our group members. Our contents will cover first about Schottky, second characteristic, third uses of Schottky, fourth application, fifth how it works, and last one reflection of the diode for us as an IIUM student. Schottky barrier diode is a metal semiconductor junction diode that has less forward voltage drop than the PN junction diode and can be used in high-speed switching application. Schottky diode, named after Walter H. Schottky, a German physicist. Schottky diode, also known as surface barrier diode, majority carrier diode, hot electron diode, and hot carrier diode. Schottky barrier diode can switch on and off much faster than the PN junction diode, produce less unwanted noise compared to PN junction diode, and lastly, make it very useful in high-speed switching power circuit. We list out the four uses of Schottky diode. First, multiple power supply. Schottky diode can also help to keep power separated in dual power supply setup like with a main supply and battery. Second, power rectification. Schottky diode can be used in high power application thanks to its low forward voltage drop. This diode will waste less power and might reduce the size of your heatsink. Third, solar cell. Schottky diode can help to maximize solar cell efficiency with their low forward voltage drop. They also help protect the cell from reverse charge. And lastly, clamping. Schottky diode can also be used as a clamp within a transistor circuit, such as in the 74LS or 74S logic circuit. Some application of the Schottky barrier diode. First, used in radio frequency application. Second, widely used in power supplies and logic gate. Third, used to detect signals. And fourth, used as general purpose rectifier. How does a Schottky diode really work? A typical diode combines p-type and n-type semiconductors to form a p-n junction. In a Schottky diode, metal replaces the p-type semiconductor. This metal can range from platinum to tungsten, molybdenum, gold, etc. When they join with n-type semiconductor, a junction is formed between it is metal semiconductor junction, or known as MS junction. It creates a depletion layer known as Schottky barrier. The behavior of the Schottky barrier will differ depending on whether diode is unbiased, forward biased, or reverse biased state. In the image below, we have two circuits to illustrate the benefits of a lower forward voltage drop. The circuit on the left contains a conventional diode, which is silicon diode, and the one on the right is a Schottky diode. Both are powered with a 2-volt DC source. The conventional diode consumes 0.7 volt, leave only 1.3 volt to power the load, while Schottky diode consumes 0.3 volt, leave 1.7 volt to power the load. If our load required 1.5 volt, then only the Schottky diode will be up for the job. Three conditions that will determine the behavior of Schottky diode. Firstly, unbiased state. In an unbiased state, free electron will move from n-type semiconductor to the metal in order to establish balance. This flow of electron created the Schottky barrier, where negative and positive ion meets at the middle. Free electrons will need a greater supply energy than their Be voltage to overcome this barrier. Second, forward bias. In the forward bias, positive terminal of battery connected to the metal, while the negative terminal to the n-type semiconductor. In this state, electron can cross the junction from n-type to metal if the applied voltage is greater than 0.2 volt. This results in a flow of current that is typical for most diodes. And lastly, reverse bias. Connecting the negative terminal of the battery into the metal and the positive to the n-type. This state expands the Schottky barrier and prevents the flow of electric current. However, if the reverse bias voltage continues to increase, this can eventually break down the barrier. Doing so will allow current to flow in the reverse direction and may damage the component. Abu Dhar reported, the Messenger of Allah, peace and blessings be upon him, said, وَأَتْبِعْ سَيِّئَةَ الْحَسَنَةَ تَمْهُهَا. Follow a bad deed with a good deed and it will erase it. Source Sunan Al-Tirmizi, Sahih. Both students and lecturers are facing with challenges along this ERTL, and sure, it is tough for us. Everybody struggle with their own problems. However, instead of complaining, we should avoid the negativity and indulge ourselves with good surrounding to alter our weak state into a unique personality. And that's all for our presentation. Thank you guys for watching. Assalamualaikum warahmatullahi wabarakatuh.